All right, so here we have a problem that involves i's and j's. Actually, even more confusingly, the distance is given in i's and j's, 2i minus 4j. But the force is not. The force is given as 10 newtons at an angle of 150 degrees, measured counterclockwise from the positive y-axis. I'm sorry, the positive x-axis. So what I would do here, I think the easiest way to go is to figure out the I and j of the force. So if this is our x and y axis, 150 degrees, well, there's 90 right there. So we need to go another 60 degrees here. And so we're talking about a force that looks like that. This is 10 newtons. You know, the leftover angle here would be 30 degrees. So I'm going to find out how much of this is in the x direction and how much of this is in the y direction. Just find the x and y components, something we've done many times. So the x component is going to be the hypotenuse times the cosine of 30. And over here, the y component is going to be the hypotenuse times the sine of 30. The sine of 30 is 0.5, so this is just going to be 5 newtons. The cosine of 30 is 0.866, so this is going to be 8.66 newtons. So basically, the force, if you write it as an I and a j, the force is negative 8.66 I plus 5j. That's the force, and to rewrite the displacement of this object, it's positive 2I minus 4j. And so work equals force times displacement, but as we know, it's only the component of the force that's in the same direction as the displacement that give you any result. So once you have force and displacement in i's and j's, you simply multiply the i's together because they're parallel, and then multiply the j's together because they're parallel. You would never multiply an I times a j because they're perpendicular to one another. And the angle between them is 90 and the cosine of 90 is 0. So here we go. It's simply 2 times negative 8.66, which is equal to negative, I'm just going to double check my math there, negative 17.32. Now the answer is neither I nor j because work doesn't have a direction. Work is not a vector. Likewise, negative 4 times 5 would be negative 20. Again, it's neither I nor j. And so then you can just put these two numbers together. It's going to give us a total of negative 37.32 joules. So that's the final answer. And I'll just point out, if you were a little bit uncertain about how I could use positive 2I minus 4j as the displacement, it's because they were asking you how much work is done as the object goes from the origin, which is right here, out to wherever positive 2I minus 4j is, I suppose somewhere around here. So the object started at 0 and it ended at positive 2I minus 4j. So literally, its displacement looks exactly like that. Its displacement is positive 2I minus 4j. So that's why I was able to use that as the displacement value.